this kind of distribution occurs when everything has an equal chance of happening. Rolling a die as that. If we were to split this up into dice rolls, okay, each one of these would be like, there's the probability of rolling a 1 or 2 or a 3. Each one of these is 1/6 high. Okay, and if we added up those sums, that would be a uniform distribution. And if we added up those probabilities, then it would add up to 1. And that'll always happen with the probability distribution, that they'll equal 1. But for this one, now they're telling us that the height, this is about random numbers, so we could have all kinds of random numbers, like they aren't really specifying 1 0 0. We could do 1 1 1 1. Those would all be random numbers. And when you look at a random number table or a calculator or whatever that generates random numbers and make that distribution, it would be a square like this, or a rectangle. In this case, they drew a square, but it could be a rectangle. But anyways, so why is that total area 1? Well, if we just think of this from a geometric standpoint, that is 1 long, and that is 1 long, and 1 times 1 is 1, so the area would be 1. We also know that, like I was saying, that all the possibilities will have a probability of 1. So the curve is symmetric. So what's the value of the mean and the median? Well, the mean and the median will be, because it's symmetric, they'll be in the middle and they'll be equal. So halfway through the middle would be 0.5. Okay. If you think about like a normal curve, which is a symmetric curve, mean and the median are equal, which is halfway. Now, what percent of the observations lie between 0 and 0.1? Well, let's see. So between 0 and 0.1 would fall right about, I don't know, I'm guessing, right about there. Well, I know this it's this rectangle. So I know that's 1 high, and I know it's 0.1 wide, because it's between 0 and 0.1. So that area would be 0.1 times 1, what area, 1.1. So we know it's 0.1 wide times 1 high, so that's an area of 0.1. So that's the probability, or what percent of the observations? So let's change this to percentage. Should be 10% of the numbers will fall within that range. Okay. And then what percent of the observations lie between 0.6 and 0.9? Well, let's see. 0.6 is about there. 0.9 is about here. And we're looking for in between those. Well, how wide is that rectangle? I think it's 0.3, right? And it's 1 high, so 0.3 times 1, and then we'll make it a percentage by multiplying by 100. So 30% of all those random numbers will fall between 0.6 and 0.9. So that would be 0.6. I guess if we aren't including if you go 4 decimal places, 0.0061 up to let's see, 0.8999. Those would be 30% of the numbers would be in between those, or including and in between. Okay, so that's all they're trying to get you to think about, is finding these areas in this problem.